Now we're going to try and draw the dot and cross diagram for carbon dioxide. Carbon dioxide, now carbon dioxide is CO2, which means there's one carbon and there are two oxygen atoms. Now let's first analyze carbon. Carbon has a proton number of 6 and it has an atomic mass of 12. That means it has 6 electrons. There would be 2 electrons in the inner shell and there would be 4 electrons in the outer shell. Similarly, we can let's the other atom is oxygen, and oxygen is 8 and it has an atomic mass of 16. Now oxygen has an electronic configuration. It has 8 electrons. That means it's going to have 2 electrons in the inner shell and there would be a total of 6 electrons in the outer shell. Carbon is in group 4, which means that it needs how many electrons? It needs 4 electrons to complete its outer shell. And since both of them are non-metals, that means it's going to a sharing of electrons is going to occur. Covalent bonding would be the result. Since it needs 4 electrons, that means it's going to share 4 electrons. Similarly, oxygen needs how many electrons? It needs 2 electrons, which means that it's going to share 2 electrons. So, and oxygen is in group 6. So if we what we just studied right now, group 6 is going to share 2 electrons, group 4 is going to share a total of 4 electrons. Now let's start drawing, and we're only going to draw the outer shells. I'm going to draw one carbon atom, and it's going to be overlapping with one oxygen atom. This is the carbon atom, and this here is an oxygen atom. Now carbon is going to share, carbon needs to share, let's write this down, it needs to share 4 electrons, and oxygen needs to share a total of 2 electrons. And what we just studied right now, before this lecture, we said that atoms are going to share electrons equally. So it can't be possible that carbon would be sharing 4 electrons and oxygen would be sharing 2 electrons. What's going to happen is that carbon would share 2 electrons with this oxygen, and oxygen in return would share 2 electrons with with this carbon atom. So instead of sharing 4 electrons, carbon is going to share just 2 electrons because the electrons have to be shared equally. Now there's a problem. Oxygen has shared its 2 electron. So how many electrons are left behind? It had 6 electrons in total in its outer shell. Since it has shared 2 electrons, there would be 4 electrons which are left behind. But for carbon, it has shared 2 electrons and it needs to share 2 more electrons. What it does is there must be another oxygen atom, and carbon ends up sharing 2 of the electrons with that oxygen atom, and oxygen in return would share another 2 electrons with that carbon atom, and there would be 4 electrons of oxygen that would be left behind. So now if you can check, there would be 8 electrons in total in each of the atoms, and this completes the outer shells of all the atoms. So this is the dotted cross diagram for a CO2 molecule. Now we're going to try and draw a molecule of NH3, which is ammonia. Ammonia is NH3. Now, ammonia has one nitrogen and it has 3 hydrogens. Now, nitrogen, which is 7 and 14, nitrogen is in group 5. And since the electronic configuration of nitrogen is going to be, it has 7 electrons, so it's going to have 2 it's going to have 2 electrons in its inner shell. It's going to have 5 electrons in its outer shell. which basically means that nitrogen needs three electrons, and since it's in group 5, it needs three electrons, so it's going to end up sharing three electrons. On the other hand, you have hydrogen, which is 1 and 1, which basically means it only has one electron. That means there's only one shell, and that's going to have one electron. So to complete its outer shell, it would need another electron because the first shell can accommodate a maximum of two electrons. So it needs two electrons. So it needs one electron to complete its outer shell. Since it needs one electron, it is going to share one electron. Now again, we have a problem that the electrons are not being shared equally. Nitrogen needs to share three electrons, whereas hydrogen wants to share one electron. So I'm going to draw the outer shell of nitrogen. This is nitrogen, and I'm going to draw the outer shell of hydrogen. And let's draw a smaller atom because hydrogen is a smaller atom. It only has one electron. Now the problem now is that nitrogen wants to share three electrons, whereas hydrogen wants to share just one electron. And I told you previously that the number of electrons shared are always shared equally. So what's going to happen between nitrogen and hydrogen is that one electron would be shared by nitrogen and another electron would be shared by hydrogen. Hydrogen is going to share one electron and nitrogen would share just one electron. But the problem now is that hydrogen has completed its sharing. It wanted to share one electron and it has been able to share one electron. The problem is with nitrogen, it still needs to share two more electrons. So you would need another hydrogen, which is going to go over there. Nitrogen is going to share another electron with that hydrogen, and hydrogen is going to share an electron back with that hydrogen. So nitrogen now shares another electron with that hydrogen, but nitrogen still needs to share three electrons, and there's still one electron remaining. So you're going to have another hydrogen. That hydrogen ends up sharing an electron with nitrogen, and nitrogen shares an electron back with that hydrogen. So now nitrogen has shared three electrons, and each of the hydrogen is sharing one electron each. Nitrogen had a total of five electrons in its outer shell, and out of those five electrons, it has shared three electrons, which basically means that there are two electrons which are still remaining, and those two electrons will be drawn which are not taking part in the sharing. And if you want to check whether the covalent dotted cross diagram is correct or not, you can simply count the number of electrons. Hydrogen needed to have two electrons in its outer shell, and if we count it, it is having two electrons in its outer shell. Similarly, this hydrogen also needed two electrons in its outer shell. It needed one electron. It shared one electron. It ended up having two electrons. This is also having two electrons. If you count the number of electrons around nitrogen, that is having a total of 8 electrons around it. Now we are going to do another example, and this time we're going to try and draw the dot and cross diagram for methane. Methane is the name given to CH4, which means that there are four hydrogen atoms bonded to a single carbon atom, and since both of them are non-metals, so this would be a covalent molecule. Carbon is 6 and 12. It is in group 4. It has a total of 6 electrons, and the electronic configuration is they're going to be 2 electrons in the inner shell. There would be 4 electrons in the outer shell. And if you uh, uh, the number of electrons needed to complete the outer shell to get a stable configuration, carbon needs carbon needs 4 electrons, and since it needs 4 electrons, it's going to end up sharing 4 electrons. On the other hand, we again have hydrogen with us. Hydrogen is 1 and 1, which basically means it only has one electron. Hydrogen is not part of any group. it only has one electron, and to complete its outer shell, the outer shell of hydrogen, which is the first shell, it has to have two electrons. So it needs just one electron to complete its outer shell. So it's going to share just one electron. So if we draw a carbon atom, so I'm going to draw a circle over here, and there's going to be an overlapping circle which would represent hydrogen. So this is hydrogen and this here is carbon. Now carbon needs to share four electrons, hydrogen can only share one electron, and I told you the number of electrons shared are always they always shared equally. So what happens is that carbon can only share one electron with this hydrogen, and this hydrogen is going to share one electron with this carbon. So hydrogen has shared its one electron, but carbon still needs to share three more electrons. So there would be another hydrogen, and that hydrogen would share one electron with that carbon, and that carbon would share one electron with that hydrogen. Now, um, hydrogen has completed its outer shell, it has shared one electron, but carbon still needs to share two more electrons. So there has to be another hydrogen, and that hydrogen would share one electron with that carbon, and the carbon would share one electron back with that hydrogen. And finally, carbon has now shared three electrons, it needs to share four electrons, so there would be another hydrogen atom, and that hydrogen atom would share one electron with that carbon, and the carbon would share one electron back with that hydrogen. Now the number of electrons shared by carbon are, so carbon ends up sharing four electrons, and hydrogen, each of the hydrogen shares one electron. So now the number of electrons shared, carbon needed to share four electrons, it has shared that, hydrogen needed to share one electron, it has shared that. So this is the shape of a CH4 molecule. And if you want to know how many electrons are left behind in the outer shell, you can look at carbon. Carbon just had four electrons, and it ended up sharing all those four electrons. So there are no electrons left behind. Hydrogen just had one electron, and it ended up sharing that one electron. So there are no electrons left behind. We can do another example, and this time we can discuss the bonding in water. And water is H2O, which means that there are two hydrogen atoms and one oxygen atom, and they're all bonded together. So quickly, oxygen is 8 and 16, which basically means it has 8 electrons, which means there are 2 electrons in the inner shell and the 6 electrons in the outer shell. It's in group 6. So it needs 2 electrons to complete its outer shell, which basically means that it's going to share 2 electrons, and they're going to form covalent bonds because both of them are non-metals. On the other hand, we have hydrogen, which is again 1 and 1, which means it has only one electron, and it needs one electron to complete its outer shell, to get 2 electrons in its outer shell, which is the first shell. So it's going to share one electron. So I'm going to draw an oxygen molecule, and I'm going to draw a hydrogen next to it. Now hydrogen needs to share one electron, whereas oxygen needs to share two electrons, and the electrons have to be shared equally. So what happens is that hydrogen shares one electron with this oxygen. This oxygen shares one electron back with this hydrogen, but oxygen still needs to share one more electron. So you would have another, so there would be another hydrogen, and that hydrogen would share one electron with the oxygen atom, and that oxygen atom would share one electron with that hydrogen atom. Now, in total, oxygen is sharing two electrons, one with this hydrogen and one with this hydrogen. And from out of the six electrons, it has shared two electrons, which means that oxygen has four electrons which are remaining and which are left unshared. So this is the dot and cross diagram for an H2O molecule. And if you count the number of electrons in each, the two electrons in the outer shells of hydrogen, which means that its outer shell is complete. The eight electrons in the outer shell of oxygen, which means that its outer shell is also complete. And there are two electrons in the outer shell of this hydrogen. So this is a perfectly correct dot and cross diagram for an H2O molecule. In our next example, we're going to try and draw the dot and cross diagram for a covalent compound which is called phosphorus trichloride. It's phosphorus trichloride, and the formula of this compound is PCl3. So we're going to try and draw the dot and cross diagram for PCl3. The first thing is we're going to look at phosphorus first. You can find it in group 5. It is 15. The proton number is 15, and the atomic mass is 31, which means it has 15 electrons. And if you arrange those electrons, there would be 2 in the first shell, and there would be 8 in the second shell, and there would be 5 in the last shell. It's a group 5. It has 5 valence electrons, which means to complete its outer shell, it needs how many? It needs to have 3 electrons. It needs 3 electrons, and what it's going to do to get those 3 electrons, it is going to end up sharing 3 electrons. So phosphorus would share 3 electrons. It has 5 electrons in its valence shell. On the other hand, you have chlorine. Now chlorine Cl is 17 and it's 35, which means that it has a total of 17 electrons, which means that there are 2 in the first shell, 8 in the second shell, and there are 7 electrons in the last shell, which means that chlorine needs just 1 electron to complete its outer shell. It needs to have 8 electrons in the third shell, and it will eventually end up sharing 1 electron. So it needs 1 electron. It's going to share electrons. So phosphorus would share 3 electrons, whereas chlorine would share 1 electron. Now draw let's draw phosphorus. And I'm going to draw a chlorine next to it. Now this is phosphorus and this is chlorine. Phosphorus needs to share 3 electrons, whereas chlorine needs to share 1 electron, and electrons are always shared equally, which means that phosphorus can only share 1 electron with chlorine, and chlorine would share 1 electron with phosphorus. And since chlorine had 7 electrons and it shared 1 electron, that means that it has 6 electrons remaining which have not been shared in the outer shell. Now, so far, chlorine has completed its job. It wanted to share 1 electron. It did it. Phosphorus needed to share 3 electrons. It has right now just shared 1 electron. So to share 2 more electrons, it would need another chlorine. And what phosphorus would do with that chlorine is that chlorine would also like to share 1 electron. So 1 electron would be shared by that chlorine, and phosphorus would share 1 electron back with that chlorine. Eventually, chlorine has shared 1 electron out of the 7 outer electrons, which means that there would be 6 electrons remaining, which would be, and this should be drawn with crosses, since I'm representing the electrons of chlorine by crosses. So this chlorine has done its job. It wanted to share 1 electron. It ended up sharing 1 electron. Now phosphorus is sharing 2 electrons, and it wanted to share 3 electrons. So there has to be another. There's going to be another chlorine That chlorine would share one electron with phosphorus. Phosphorus is going to share one electron with that chlorine. Eventually, there would be 6 electrons of chlorine remaining, which would be unshared. Now, phosphorus has shared 3 electrons, one over here, and one on this side with this chlorine. So it has shared 3 electrons. It had 5 electrons in its outer shell, and from out of that 5 electrons, it has shared 3, which means that there would be 2 electrons remaining behind, which would be unshared. And to check whether we have drawn a correct dot and cross diagram, you can count the number of electrons. Each atom now has 8 electrons in its outermost shells, which means that this is a correct dot and cross diagram. Remember to represent the electrons of one element by crosses and the electrons of the other element by dots. In this case, I've represented the electrons of phosphorus by dots and the electrons of chlorine by crosses. So this is the dot and cross diagram for PCl3 molecule, which is covalently bonded. Now I'm going to try and draw the dot and cross diagram of a slightly more tricky molecule, which is slightly more difficult. We're going to draw the dot and cross diagram for hydrogen, cyanide, which is H, C, and N. Let's underline this. So we're going to try and draw the dot and cross diagram for an HCl molecule, and it has a hydrogen atom. Hydrogen has an electronic configuration. It only has 1 electron in its outer shell. It needs 1 electron to complete its outer shell, so it's going to share 1 electron. On the other hand, carbon, it's 6 and 12. Carbon has an electronic configuration of 2 and 4. It needs 4 electrons to complete its outer shell, so it's going to share 4 electrons. On the other hand, we have nitrogen, which has 7 as the atomic number, and it has 14, which is the atomic mass. So it has an electronic configuration of 2 and 5. It needs 3 electrons, so it's going to end up sharing, it's going to share a total of 3 electrons. Now we have these 3 molecules with us. And remember, HCN just has, there's only one H. So let's start off with the H. Start off with the carbon in the center. We have, I'm drawing a carbon atom. So this is carbon, and carbon wants to share 4 electrons. I have hydrogen. Let's draw a smaller atom, and let's draw a nitrogen. Draw a nitrogen atom. So I've drawn these two together. Now carbon needs to share 4 electrons, hydrogen needs to share 1 electron. So electrons should be shared equally. So carbon would share 1 electron with this hydrogen, and this hydrogen would share just 1 electron with this carbon. So hydrogen has done its job. It wanted to share 1 electron. It has shared 1 electron. On the other hand, carbon still has to share 3 more electrons, whereas nitrogen needs to share 3 electrons. So the number of electrons that both the atoms are wanting to share are now equal, because carbon has already shared 1 electron with hydrogen. So you have carbon, and it's going to share 3 electrons with this nitrogen. Nitrogen is going to share 3 electrons back with this carbon atom. Carbon had 4 electrons in its outer shell, which means it has shared all those 4 electrons. There are no electrons left behind. Whereas nitrogen had 5 electrons in its outer shell. It has shared 3 of those electrons, so there are 2 electrons that are left behind. So this is the dot and cross diagram for an HCN molecule. Now we are going to try and draw the dot and cross diagram for hydrogen chloride, which is also called HCl. There is one hydrogen atom and there's one chlorine atom. Now let's take hydrogen first. Hydrogen is 1 and 1, which means that it has 1 electron in its outer shell, and it's going to share 1 electron. Similarly, you have chlorine. Now, chlorine is it is 17. The atomic number is 17, and the atomic mass is 35. So chlorine has 17 electrons, which means that it has 2 electrons in the first shell. There are 8 electrons in the second shell, and there are 7 electrons in the last shell. It's in group 7, and it needs 1 electron. Since it needs 1 electron, it's going to end up sharing 1 electron. Now, if you look at both atoms want to share 1 electron. So we're going to draw a chlorine atom, and we're going to draw a hydrogen atom. So I've drawn one hydrogen atom, and this is chlorine, and this over here is hydrogen. Hydrogen wants to share 1 electron. It's going to share that 1 electron. Chlorine wants to share 1 electron, so chlorine would share 1 electron. And hydrogen just had 1 electron. So if it shares 1 electron, then its outer shell is complete. There are 2 electrons in its outer shell, which is the first shell, and it doesn't have any electrons left behind. Whereas chlorine had a total of 7 electrons in its outer shell, and it's sharing only 1 of those. So there are 6 electrons which are left behind. So this is the dot and cross diagram for an HCl molecule. Our next example is a hydrazine molecule, which hydrazine also called the formula of hydrazine is N2H4. Now there are a total of 2 nitrogen atoms. There is 1 hydrogen atom. So let's deal with hydrogen first. Its proton number is 1. That means it has 1 electron. It needs 1 electron to complete its outer shell. So it's going to share just 1 electron. On the other hand, you have nitrogen, which has a proton number of 7 and atomic mass of 14, which means it has 7 electrons. So the electronic configuration is going to be 2 electrons in the first shell, and there would be 5 electrons in the second shell. So it needs how many electrons to complete its outer shell? It needs 3 electrons. So nitrogen is going to end up sharing 3 electrons in total. So nitrogen wants to share 3 electrons, hydrogen wants to share just 1 electron, and the formula of the compound contains there are 2 nitrogen atoms, and there are 4 hydrogen atoms. So we can start off with by drawing. I've drawn a nitrogen atom, and it wants to share 3 electrons. So I've drawn a nitrogen atom, but hydrogen is only able to share 1 electron. So what hydrogen would do is that it's going to share 1 electron, and nitrogen would share 1 electron with that hydrogen. So this here is a hydrogen atom. Hydrogen would share 1 electron, and nitrogen is going to share 1 electron with that hydrogen. Now the problem is nitrogen still wants to share 2 more electrons. It wants to share a total of 3 electrons. So you would need another hydrogen. So I've drawn another hydrogen. That hydrogen would share 1 electron with that nitrogen, and the nitrogen atom would share another electron with that hydrogen. Now the only thing left is nitrogen needs to share a 3rd electron, and you can have another hydrogen, but the problem with that would be that then the structure of the molecule would be complete, but we have a lot more atoms in this particular compound. So what I can do is the 3rd electron of nitrogen can be shared by, we have 2 nitrogen atoms. So I'm not going to use hydrogen over here. We have 2 nitrogen atoms. So I've drawn the 2nd nitrogen atom, and what happens is that these 2 end up sharing an electron in the center. Now, And since this nitrogen is sharing 3 electrons, it had a total of 5 electrons in its outer shell. So if it's sharing 3 electrons, there would be 2 electrons which would be left behind. You can check that the electronic configuration of this nitrogen is now complete. It has 8 electrons in its outer shell. For hydrogen is also complete. For this hydrogen is also complete. But the problem is that this nitrogen has only shared 1 electron. It needs to share 2 more electrons. So you're going to have 2 hydrogens. This nitrogen would end up sharing an electron with this hydrogen, and the hydrogen would share an electron back. So that's 1 hydrogen, and then there would be another hydrogen. So there's another hydrogen that would share an electron with this nitrogen, and that nitrogen is going to share an electron back with that hydrogen. And now nitrogen has shared 3 electrons. It had a total of 5 electrons. So there are 2 electrons which are remaining in this molecule. So this is the dot and cross diagram for hydrazine. Now in this example, we're going to try and draw the molecule of ethene. You're going to learn a lot more about ethene when you study organic chemistry. I'll tell you, ethene is C2 and H4. It has 2 carbon atoms and it has 1 hydrogen atom. So let's focus on carbon first. Carbon has a proton number of 6, and it has an atomic mass of 12, which means it has 6 electrons in total, which would mean there would be 2 electrons in the first shell and there would be 4 electrons in the second shell. And carbon would need 4 electrons to complete its outer shell. So it's going to end up sharing 4 electrons. It's in group 4. It needs 4 electrons. It ends up sharing 4 electrons. Similarly, we have hydrogen at the other end. And hydrogen was 1 and 1, which means that it's going to end up sharing. It needs 1 electron to complete its outer shell. So it's going to share 1 electron. So we have carbon which is sharing 4 electrons. We have hydrogen which is sharing just 1 electron. So I'm going to draw, the first thing that I'm going to draw is I'm going to draw a carbon atom. So I've drawn a carbon atom, and carbon needs to share, how many? It needs to share 4 electrons. So let's draw a hydrogen atom, and they're overlapping. Hydrogen needs to share 1 electron, carbon needs to share 4 electrons. What they're going to do is they're going to share 1 electron each. So there's 1 electron being shared between the 2. But carbon still needs to share 3 more electrons. So there has to be another hydrogen. That hydrogen is sharing 1 electron. Carbon is going to share 1 electron back with that hydrogen. So you have this structure. The hydrogens have completed the outer shell. They wanted to share 1 electron. They have been able to share 1 electron. The problem is with this carbon now, it needs to share how many electrons? It needs to share a total of 4 electrons. It has only shared 2 electrons right now. So I'm going to draw another carbon with it. And let's say this carbon over here is going to share another electron. So it's going to try and share an electron with this carbon in return shares an electron with this other carbon. But there's going to be a problem. I'm left with 2 hydrogens now. This carbon needs to share 4 electrons as well. It's sharing 3 electrons. It's sharing only 1 electron right now. So there's got to be another hydrogen with that, and that hydrogen would share 1 electron with that, and carbon would share another electron back with that. And this carbon needs to share. There's 1 hydrogen left in our formula. We had 2 carbon atoms. These are our 2 carbon atoms, and we had 4 hydrogen atoms. And this is 1, this is 2, and this is the third one. So the fourth has to be put somewhere, and I'm putting it over here. So this fourth hydrogen is sharing an electron with carbon, and carbon is going to share an electron back with that hydrogen. Now there's a problem. carbon needs to share 4 electrons and we have run out of atoms. This carbon also needs to share 4 electrons. It has already shared 3 electrons. This carbon has also shared 3 electrons. So both carbon need to share 1 more electron, and what they can do is this wants to share 1 electron, this wants to share electron. So there's, instead of a single bond, there's going to be a double bond. So I'm going to draw 2 more dots over here indicating that there are a total of 4 electrons being shared between these 2 carbon atom, and this particular bond is now called a double bond instead of a single bond.